Fine. Now, general angles and radian measure. Angles is rotation. So basically what you need to think is the angle always, it has an initial sign over here. Correct?
Yeah.
It's the initial sign and you rotate that angle. When you rotate that angle anti-clockwise, counterclockwise, it's taken to be positive. So counterclockwise angle is taken to be positive. Counterclockwise is taken to be positive, and this is positive angle when you go like this, and this is your negative. Correct? So you always start from this. You always start from the x-axis, and you rotate.
Okay.
So represent each of the angle as a this. So what do you do is you have to just draw that. Draw that. One second. Let me zoom in. It's too small there. Okay. Yeah. So when you're drawing that, so you'll draw this. You'll draw this. This is 150 would go in here. So this is your 150 degrees. Correct? X and this is your Y. 315.
So it would be close to the straight line. So it would be something like...
Yeah. Like 315 would be this.
Oh yeah, like that, yeah.
Correct? No, because 19, 9 2s are 18, 9 3s are 27, 270 and 45. Yeah. So basically you're falling 45 short of 360.
Yes, so 360 is there, right?
Yeah, 360 is the entire circle. So you're falling short you're falling short by 45 degrees.
Yeah.
Minus 120. So you go this way then. So 90 and 30. So
yeah.
This is your minus 120. So clockwise.
Yeah.
Okay. Represent 90 degrees, 450 degrees, minus 270 as rotation and standard position. So if you have 90, so this is your 90 degrees, correct?
Yeah.
450.
It would be
9 2s are 18, 9 3s are 27, 9 4s are 36, 9 5s are 45.
Yeah.
Correct? So you're coming back there only.
Yeah.
So this is your final arm is coming here. Here also your final arm is coming here. Okay? And minus 270.
It would be straight, right? But down.
This is a minus 270. Why down? Rohan, minus 270. Minus 270.
Because it then goes up again. Because it comes from counterclockwise and goes to 270.
Yeah, this is clockwise. Negative angle is clockwise and positive angle is counterclockwise. So what do you observe? They are the same. They are ending at the same. The terminal arm.
The same.
The terminal arm is at the same position.
Yeah.
Terminal arm is at the same position.
Yeah.
So the angles with the same terminal side, are called co-terminal angles. You can find co-terminal angles by adding or subtracting 360 degrees. Correct?
Okay. Yeah.
So 315.
Yeah.
So this is your 315. So which will my co-terminal angle be? So suppose if I these are my same terminal side. So you start from here, the same terminal sides. So what will my co-terminal angle be?
45.
Minus 45.
Yeah.
Correct? Or you can add 360 to this. 315 plus 360 is how much?
Is 675
degrees. So all these are examples of co-terminal angles. There can be several co-terminal angles. So basically you add or subtract multiples of 360. You can also do plus 720. You can go on adding 360 to this.
So wait, on this is 0, like this is 0, then that's 90, that's 180, that's 270, then that's 360.
Yeah, correct. Yeah, so if you have this is 0, this is 90, this is 180, This is 270, this is 360. And so on.
Okay.
And so on.
Yeah.
Minus
Okay.
120.
So
90.
that would be.
Yeah, this is your minus 120.
Yeah.
Now which will my coterminal angle be? So can I look at this angle?
Yeah.
So how much will that be?
That would be it would be 360 minus 120, right?
Yes.
So that would be 240.
240. Can you give me another coterminal angle?
Can you do minus 120 plus 360?
That's what we did now.
Oh yeah, no. That's what I'm saying.
You can also do minus 360 minus 120.
Yeah.
That's minus 480.
Yeah.
You can also do 720 minus 120, 600.
Yeah.
Basically, any multiples of 360 you can take and add and subtract from 120.
Okay.
Minus
I see.
120.
Yeah, that's okay.
Write the formula for measure of all the angles coterminal with 150. So what will you do? 150 plus or minus multiples of 360.
Yeah.
When belong to integers.
Okay. Nice.
You following that? You have to only do what?
Sorry, say again?
You have to do what? Multiples of 360.
Multiples of 360, yeah, because you can't
Add or subtract multiples of 360 from it.
Yeah. Yeah.
It is time for a brief look at how this works with trigo. We'll have to do a lot more of this in the next couple lessons. Thank you. Now, draw angle theta in the standard position whose terminal arm passes through 8,6.
Okay. Terminal side is where the angle is, right?
So when you have an angle, this is your terminal side. Your initial side, and this is your terminal side.
Okay.
So this is a terminal side. This is your terminal side.
Right. Yeah.
This is your terminal side.
Yeah.
So your initial side is always on the x-axis. So 8,6 is somewhere here. So P is 8,6. Correct? Draw an angle, standard position, terminal side. So the terminal side passes through 8,6. So this is my terminal side. So this is the angle theta. Correct? So then what you do is, can you complete this triangle? Yeah? So this would be 8.
Because and that'd be 6.
By Pythagoras, can you find this out? How much will this be?
64 plus 36.
Correct.
Is 100. So 10.
10. So what are the 6 trigo ratios? So what is your sine theta?
Sine is 6 over 10.
Perfect. Cos?
Okay. Cos is 8 over 10.
Yeah. 10.
6 over 8.
Perfect. Cosec?
It's the opposite. So 10 over 6.
Not opposite. Don't say opposite. Reciprocal.
Sorry, no. Reciprocal. Sorry,
Yeah.
reciprocal.
10 over 6. Sec?
10 over 8. 10 over 8. 8 over 6.
Angles can be measured in degrees on another kind of unit called radians. As we'll see in chapter 14, radians are generally used in non-geometric applications of trigo. Here's a definition of radians. So, if you have a circle of radius r and you take an arc of length r, this angle is called 1 radian.
180.
Yeah, 1 radian. So,
Hmm.
so 1 radian is approximately 57.3 degrees, basically.
Okay.
Okay. So basically
So then how is 2 pi? Oh, because 3, okay, yeah.
So you need to remember
Okay,
basically that 360 degrees is 2 pi radians. So when you had a full circle, we said this full circle over here was 360 degrees. But if you're thinking in radians, the full circle is 2 pi radians. Remember, circumference is 2 pi r. You can remember that.
Yeah.
Correct? Because 2 pi radians is then full circle. That's the reason. So full circle is 2 pi. So 360 degrees is 2 pi radians. So if you divide both the side by 2, 180 degrees is pi radians.
Okay.
Okay.
And how would you write radians as like a letter, or you don't need to know? You can just
No,
write.
you have to
the
leave
word
it in
radian.
pi only. You have to leave it in terms of pi only.
Okay. So you just know that pi is different.
Yeah, that you have to write in terms of pi. You never put 57.3 ever.
Okay.
So pi is much more commonly used than 57.3 degrees.
Okay.
So basically, to convert degrees, if you have an angle in degrees, to convert that angle into radians, you'll multiply that angle by pi by 180. And to convert it back to degrees, you multiply it by 180 by pi.
Okay. Yeah.
So let's see over here. So convert to radians. Now there are two ways of doing it. You can say that 180 degrees is same as pi radians.
Yeah.
So 210 degrees is how many radians? You can use the unity method.
Yeah.
210 into pi upon 180.
Yeah.
So then 3 7s are 21, 3 6s are 18. So 210 degrees is same as 7 pi by 6 radians.
Oh wow, okay.
This is one way. Other way is what you take your angle and simply multiply by pi by 180. Just that's it. If you don't want to use the unity method, same answer you'll get.
Oh wow, okay.
So either you use unity method, remembering that 180 degrees is pi radians, or you simply multiply the angle by pi by 180. And you'll get the answer.
Unitary method would be best, no?
Yeah, anything you like.
Yeah.
So do it for 270 degrees.
It's over 2.
So you can multiply this by. So I'll do it directly. I'll multiply this by pi by 180.
Yeah.
So 9 3s are 27. 9 2s are 18. So 3 pi by 2 radians.
Yeah.
Perfect.
That's like.
So basically what you need to remember is this is 0 radians, pi by 2 radians, pi radians. So when you go this way, it's pi radians, 3 pi by 2, 2 pi. So you can remember like this. So this is basically, this is pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, 5 pi by 2, 6 pi by 2, 7 pi by 2, 8 pi by 2 and so on.
Okay. But so you also multiply it by 1 and 2? Like, this is 2 pi, and then is it pi upon, like, it's just pi upon 2, right?
Pi upon 2, yeah. 90 degrees is pi upon 2.
Okay. And then, that makes sense.
Now how do you convert to degrees? How do you convert radians to degrees?
I can times it by 170 upon radians.
170 by 170, 180, no?
Sorry, 180, sorry.
Upon pi, don't say radians.
Upon pi, yes.
Upon pi. So pi and pi cancels. 9 2s are 18, 7 2s are 14, 140 degrees.
Yeah. Very cool.
Yeah.
So this would be
next one
minus pi upon 12 times 180 upon pi.
Correct.
Yeah. And then you cross out the pi.
Then
and then you could make that
6 2s are 12, 6 3s are 18, 2 15, so minus 15 degrees.
no. Minus because of the minus at the front. Yeah, okay.
Minus 15 degrees.
Okay.
So the diagram given below shows a unit circle. Unit circle is a circle with radius equal to 1 unit. 1 unit means either it can be 1 centimeter, 1 inches, 1 meter, anything. 1. Showing radian measure for the multiples of the special angles 30 degrees. Acha, now can you convert each of them to radians? Come on, quickly do that.
Okay. Let me try.
Yeah, convert each of them into radians. You, in your radian, you will always have pi by 6. So you see, when you multiply 30 by what, it will give you 180.
Yeah, that's what I realized. When I started doing it,
so this will be pi by 4. 45 to 4 is 180. This is pi by 3 because 60 into 3 is 180. This is pi by 2.
Yeah. 2, yeah.
Okay. Evaluate the trig functions. Can you do this without a calculator? So cos pi by 3. Now pi by 3 is how many degrees?
Pi itself is 180, right? Yeah. So that'd be 180 upon 3. So 60.
60.
So cos of 60.
Yeah. So what is that?
Oh, I know. Is it cos 60?
So what is cos 60?
1?
Half.
Half. Okay. Okay.
You have to learn that table. You have to make. You remember now how to make the table?
Yeah. I had it in my other notebook. Wait, can I get my other notebook?
Yeah. So 180.
So 45.
Sine 45. What is sine 45? 1 over root 2.
1 over root 2.
1 over root 2. Yeah. Next one.
And then tan of, that's 30. Tan 30.
Tan 30. Very good. Very good. Okay, you're catching very quickly. Huh?
That should be
1 over root 3.
1 over root 3. I'll revise the table once and I'll remember it. It's
Yeah,
just because I did it once, I never looked at it again.
Yes. Okay. Part 3. Arc length in area of a sector. Now, you know, if you have a sector,
yeah,
it is a region which is bounded by the radius and the arc of a circle. So this is the arc, this is a radius and this is a radius. Since it's bounded by 2 radiuses, correct? And the arc of a circle. So this region is your sector. Okay?
Wait, what? So,
like a slice of a pizza. It's a pizza slice.
Okay.
Your pizza slice that you take is a sector.
Okay. So the inside is a sector.
Yeah, outside is also a sector. So the inner one is called the minor sector. It is called a major sector. Both these are sectors.
Okay. Bounded by 2 radiuses because there's 2 different pizzas.
Yes.
Circles. Okay.
Consider a circle of radius 10. So radius of the circle is 10 centimeters.
Yeah.
And a sector of this whose central angle is 100. So you have a sector whose central angle is 100 degrees. This is like this. This is 10. This is 10. Make a diagram. Find the arc length. What is formula of the length of the arc?
The formula for arc length?
Achha, what is formula for the circumference of a circle?
Pi r.
No. 2 pi r.
Yeah. For circumference, right?
Yeah, 2 pi r. Not pi r. 2 pi r.
I said 2 pi r.
Oh, sorry. Because the connection I must have heard only pi r. Okay.
Yeah.
This is a fraction of theta parts out of 316 to 2 pi r.
Right. The fraction of...
Yeah.
Okay, that's the formula.
That's the formula for the length of the arc. So this is my central angle, 100 over 360 into 2 pi r. R is the radius is 10. Correct? So this and this cancels off.
Yeah.
2 18s, 2 5, 2 9s are 18. So that's 50 pi upon 9.
Yeah. Oh, because of the 10. Yeah. Wow.
Area of
That's
the
very
sector?
strange.
What is the area of the sector?
Area of the sector would be length times width, right? So
Eh?
we have the length.
No, what length times width?
Oh, it's a circle. It's a circle.
Ah. So,
a circle.
so theta over 360 into pi r square.
Yes, sorry, I don't know what I was saying. And the radius is 10, so
100 over 360 into pi r square. R square is 100. Correct? Cancel, cancel. 2 5s are 10. 2 18.
18, yeah.
Then 2 9. 250.
Yeah.
So 250 upon 250 pi upon 9. Correct? Now this will be centimeters. This will be what? Centimeter square.
Centimeter squared, yeah. Okay, so arc length is what? It's just a sector.
Arc length is the length of the arc. Length of this arc. This green that I'm outlining.
Yeah. So that's the circle and you're trying to measure that arc. Okay.
Only this green part is the length of the arc.
Okay.
And area is the space that it occupies. This is the area of the sector.
Yeah.
This is the area. Achha, if they ask you perimeter, what will you do?
Add up all the sides.
Add up all the sides. So what will the formula become if you want to have a perimeter?
10 plus 10. Oh, but I don't have one side, so I have to do... Can I do Pythagoras theorem?
It's not a right angle triangle. 10 plus 10 plus the length of the arc we got now. 50 pi upon 9.
Yeah. 250.
Length of the arc we got now. 50 pi over 9.
Yes, length, yes. 50 pi upon 9, yeah.
So 20 plus 50 pi upon 9. So 180 plus 50 pi upon 9. If you take the LCM.
Yeah, okay.
So write the formulas for the arc length. What is the formula of length of the arc? I told you.
Is
theta over 360.
Theta over 360
into 2
times 2 pi r, yeah.
And what is the formula for the area of a sector?
Wait, isn't that one area? 2 pi r. Oh no, sorry. 0 upon theta upon 360 times pi r squared.
Perfect. What is the formula for the perimeter mean? The length of the arc plus 2r.
Length of the arc plus, yeah.
Plus 2r. Whatever the length of the arc you get, you add 2r to that. That's your perimeter.
Yeah.
Now, there are different versions for this formula of theta when it's measured in radians. Now, these were the formulas when your theta is in degrees. I'm putting a small degree on top. But if it's radians, what's the formula?
Radius times...
The length of the arc is r into theta. Radius times the angle in radians.
Radius times the angle, yeah.
And the area of the sector is half r square theta.
Yeah. So you do half and then you r squared the
into the
radius.
Into the theta, into the angle. Acha, do sum number 10 and send me a... Yeah, so what you have done is correct. So, length of the arc is equal to r theta. So r is the radius, 25. Theta is equal to 2 pi by 5. So that's 10 pi, correct. And the area of the sector is half r square theta, half into r square, 25 into 25 into theta, it's 2 pi by 5. So 5s are 25, 2 into cancels, so 125 pi. Perfect. A scientist performed an experiment to study the effects of gravitational force on humans. In order for humans to experience twice the gravitational Earth's gravity, they were placed in a centrifuge 58 feet long. And the diameter is 58 feet and spun at a rate of 15 revolutions per minute.
Yeah.
Through how many radians that people rotate each second? Now one revolution is how many radians? Is 2 pi radians.
Fine. How do you know that?
One circle is 360 degrees, which is 2 pi radians.
That's what it means by revolutions, like one full
One
circle.
revolution is full circle. A revolution is one full circle.
Oh, okay.
So one revolution is 2 pi radians. So now this
Okay.
is 15 revolutions.
So that's 30 pi radian.
30 pi radians. Now it's going 30 pi radians in how many minutes? In 1 minute.
I'm sorry, in 1 minute. Yes, sorry, in 1 minute.
So in 1 minute is how many seconds? 60 seconds.
60 seconds.
So in 1 second, how much?
In 1 second, we divide it by 60, so it's
Correct.
1/2 radians.
Correct.
And that'd be times 50.
So 1/2 radians. No, half radians is your answer.
Oh, yeah, sorry, because we already divided by 60, yes.
Half pi, basically half pi radians per second.
Yeah, it's asking per second. Yes, that's why, yeah.
Find the length of the arc which people rotated in each second. What is formula length of the arc?
Formula is
R theta.
yeah, r theta.
What is R?
R is the radius.
So what is the radius?
Half of 58.
That's how
so
much?
26.5. Sorry, 20.
29.
Sorry. Not 26.
29 into half pi.
Yeah, yes, sorry, 29. Sorry.
Yeah. 14.5 pi.
14.5. Yeah. I don't know what I'm saying.